Configure single area OSPF version 2. Topology, I will use 4321 routers and 2960 switches. R1, S1, S2, R2, and the connections gigabit 001 to S1, fast Ethernet 5. Between switches, fast Ethernet 1 in both sides. And on R2, gigabit 001 to fast Ethernet 5 on S2. The loopback 1. Loopback interface on each router. This is the addressing table. Okay, and this is the network here. 1053.00 prefix 24. Okay, subnet mask prefix 24. And on loopback 1, the network on R1 is 172.16.10.24. And the loopback on R2 is 192.168.10.24 according the addressing table. Okay, loopback 1 on R1 and loopback 1 on R2. 3 subnets, 3 networks. Configure basic settings for each router. Device name on each router. Device name to each switch. These another configurations were made in another labs, so for this lab for me is optional. Same way on switches. Configure and verify single area OSPF version 2 for basic operation. Configure interface addresses. Configure interface addresses and basic OSPF version 2 on each router. Configure interface addresses on each router as shown in the addressing table above. First, R1. No, enter configure terminal. Don't forget the hostname R1. Interface gigabit 001. IP address. This IP address 1053.01. 1053.01. Subnet mask 24. No shutdown. Okay, and loopback 1. Interface loopback 1. IP address 172.16.11.24. Okay. On R2, gigabit 001 and loopback 1. No enable configure terminal interface gigabit 001 IP address 1053.02 prefix 24. No shutdown. and loopback 1, 192.168.1.1. Interface loopback 1. Enter IP address 192.168.1.1. Subnet mask 24. Configure interface addresses on each router. Already done. Enter OSPF router configuration mode using process ID 56. Okay, on R1, exit on global configuration mode, router OSPF, process ID 56. Enter. Configure a static router ID for each router. 1 for R1 and 2 for R2. Okay. Router ID. This is R1, so use 1.1.1.1. Enter. Configure network statement for the network between R1 and R2, placing it in area 0. If you will configure single area OSPF version 2, only use area 0 for all configurations. Okay, network statement. When you configure a network statement, you need to configure the directly connected networks. Okay. For R1, there are 2 directly connected networks. This 172.16.10.24 and this 10.53.00.24. If you want to see on the router, you can use do show IP route connected command, and you will see both networks. But it says configure a network statement for the network between R1 and R2. Only the network between R1 and R2. And the network between R1 and R2 is 10.53.00. Only 10.53.00. Only this. Okay. Network 10.53.00, and the wildcard for prefix 24 is this. Okay. Okay, and place on area 0. Area 0. Okay, space area 0. Enter. Remember, this is the inverse subnet mask, also called wildcard mask. How to allow this? Very simple. The prefix is 24. The prefix is 24, and decimal is this 255, 255, 255. That's 0. And do the following operation: minus 255 minus 255, 0, 0, 0. 255 minus 0 is 255. And this is the wildcard. Okay, when you have another subnet, for example, prefix 30 is 252. 255 minus 252 is 3. Okay, in my case is this. Okay, and now configure R2. Okay, exit, configure R2, enter, enable configure terminal, router OSPF, process ID 56. Okay, enter. The process ID can be different, not problem if you will use, for example, 70. Okay, it's only local ID. Okay, and router ID 2 for R2, router ID 222. Configure a network statement for the network between R1 and R2, placing it in area 0. Do show IP route connected to view the directly connected networks. And this is the network between R1 and R2, this network. Network 105300, wildcard for 24 is this, and area 0. Okay, and wait a moment. And you will see the neighbor adjacency with this router ID 1111. It's the router ID of R1. Okay, enter. Only on R2 add the configuration necessary to advertise loopback 1 network into OSPF area 0. Okay, advertise loopback 1 network on R2, only on R2. And is this network 192.168.10.000.255 area 0. Enter. Verify and exit. Verify OSPF version 2 is operational between the routers. Issue the command to verify R1 and R2 have format and adjacency. Okay, don't forget the hostname on R2. Hostname R2, enter. Okay, and on R2, exit. On privilege exec mode, use the following command: show IP OSPF neighbor. Enter. And you will see you have a neighbor. The neighbor ID is 1111, the ID for R1. On local interface gigabit 001. On local interface gigabit 001. Okay. Okay, on local interface gigabit 001. On R1, use the same command to verify. Enter. Exit. On privilege exec mode, show IP OSPF neighbor. Enter. The neighbor is R2 with router ID 2222 and local interface gigabit 001 on R1. Local interface gigabit 001 on R1. Okay, gigabit 001 on R1. And the address, this is the address of the neighbor 105302. The address of gigabit 001 interface on R2. Gigabit 001 interface on R2, 105302. 105302. Which router is identified as the DR, designated router, which is the backup designated router, BDR. What was the selection criteria? Go to R1, and on R1, the state of the neighbor is full backup designated router. Okay, And who is the neighbor? The neighbor is R2 and is a backup designated router. So R2 is the BDR. And go to R2. The state is designated router. And who is the neighbor? This R1. So R1 is the designated router, the DR. Another way to verify this is verify the configuration of and verify the OSPF configuration on gigabit 001 on R2. Show IP OSPF interface gigabit 001. Enter. And you will see router ID 222. This is R2. Okay, the state for R2 is backup designated router, BDR. And the designated router is router ID 1111, R1. And the backup designated router is R2. Very nice. In this example, R1 was configured first and was speaking OSPF before R2. So during the OSPF election, only R1 was configured for OSPF and became the designated router, DR. After R2 was configured for OSPF, it became the backup designated router, BDR, on the gigabit segment. The router with the highest router ID is used in the selection of DR and BDR. On R1, issue the show IP route OSPF command to verify that the R2 loopback 1 network is present in the routing table. Go to R1, show IP route OSPF, enter. Now you will see the OSPF neighbor 192.168.1.1. Okay, this is the loopback on R2. But look at this, it's not a network address, it's a host address. Notice that the default behavior of OSPF is to advertise a loopback interface as a host route using a 32-bit mask. Okay. 32-bit mask and host address. Only for loopbacks. If you will use only show IP route, you will see two directly connected networks, the network between R1 and R2, the network of directly connected network of loopback 1 here, and the remote OSPF network of R2, loopback on R2. Okay, go to R2 and show IP route. And you will see only two directly connected networks. The network between R1 and R2, and the network of loopback 1 local interface. And you will not have a route for loopback on R1 because, remember, was not advertised in OSPF. Ping the R2 loopback 1 interface address from R1. From R1, ping loopback 1. Go to R1 and ping 192.168.1.1. Remember, the address of loopback 1 on R2 is 192.168.1.1. Enter. Success. 100%. Optimize the single area OSPF version 2 configuration. Implement various optimizations on each router. On R1, configure the interface gigabit 001 OSPF priority to 50 to ensure R1 is the designated router. Okay, on interface gigabit 001, on R1, configure terminal interface gigabit 001. This interface gigabit 001 priority 50 IP OSPF priority 50. Okay, is OSPF. Enter. Very good. Configure the OSPF timers on gigabit 001 of each router for a hello timer of 30 seconds. The hello timer by default is 10 seconds, so change this to 30. IP OSPF hello interval 30. Okay, enter. This configuration was made on the gigabit 001 interface. And on each router, so on gigabit 001 on R2 configure terminal interface gigabit 001 IP OSPF hello interval 30. On R1, configure a default static route that uses interface loopback 1 as the exit interface. On R1, enter exit on global configuration mode, IP route, default static route, and use the interface loopback 1 as the exit interface. Loopback 1. Okay, don't worry about this message. Propagate the default route into OSPF. R1 enter to router OSPF process 56. Enter propagate with default dash information originate command. On R2 only, add the configuration necessary for OSPF to treat R2 loopback like a point-to-point network. This results in OSPF advertising loopback using the interface subnet mask. Okay, only on R2. Go to R2, enter loopback 1, interface loopback 1, point-to-point network, IP OSPF network point-to-point. Enter 2 dash points. Enter. Exit. Okay, verify this. Go to R1. Okay, exit from router configuration mode, exit from global configuration mode. On privilege exit mode, show IP route, OSPF. You will see the network address or subnet address. Previously, the host address 1.1, and now, after configuring the point-to-point network on interface, on loopback interface on R2, on R1 you will see the network address. On R2 only, add the configuration necessary to prevent OSPF advertisements from being sent to the loopback network. Okay, on R2, configure passive interface, the loopback 1. Because loopback 1 does not have a neighbor router as a neighbor on this side. Okay, on R2, enter to router OSPF56, passive interface is loopback 1. Change the reference bandwidth of each router to 1 gigabit per second. Okay, go to R1, configure terminal. This should be on router configuration mode, router OSPF 56 auto cost reference bandwidth. Okay, 1 gigabit is 1000 megabits, so use 1000. Okay, enter. Okay, please ensure reference bandwidth is consistent across all routers, so configure also on R2. On router OSPF 56, on router configuration mode, auto cost reference bandwidth 1000. 1000 megabits is 1 gigabit. Enter. Very good. Okay, and after this configuration, restart OSPF using the clear IP OSPF process command. Okay, and on global and privilege exit mode, clear IP OSPF process. Enter OSPF process. Enter. Reset all OSPF processes. Yes. Enter R1. Enter and privilege exit mode. Clear IP OSPF process. Enter. Yes. Enter. Now the console message after setting a new reference bandwidth. Verify OSPF optimizations are in place. Issue show IP OSPF interface gigabit 001 command on R1. And verify that the interface priority has been set to 50 and that the time intervals are hello, 30, dead, 120, and the default network type is broadcast. Okay, on R1. Enable show IP OSPF interface gigabit 001. priority 50, time intervals hello 30, okay, that 120, that 40. Remember, on this step, configure the Ospf timers, the gigabit 001 of each router for a hello timer of 30 seconds. You only modified the hello timer to 30 seconds. The default is 10 and you changed this to 30. So that's why it's 30. But the default value for that interval is 40. Okay, and it's still 40 because this value was not modified. If you want to modify this to 120, use the enter to interface gigabit 001 and use the IP OSPF that interval and change the value to 120. But for now it's 40 and this is okay. Default network type broadcast. Okay, broadcast. Show IP route OSPF. Show IP route OSPF. Enter. Verify that R2 loopback1 network is present in the routing table. Okay, loopback1 on R2 is the network, not the host, is the network. Notice the difference in the metric between this output and the previous output. Also note the mask is now 24 bits as opposed to the 32 bits previously advertised. Okay, the metric is 10 and is the network address. Previously the metric was 2 and this is the host address. Show IP route OSPF on R2. R2, enter, enable show IP route OSPF. The only OSPF route information should be the default route R1 is propagating. The default route using OSPF. Metric 1. Ping R1 loopback1 interface address from R2. From R2, ping loopback1. Ping 172.16.11. Success. Why is the OSPF cost for the default route different than the OSPF cost at R1 for the 192.168.10.24 network? A default static route imported into OSPF is given the metric type of external type 2, E2, by default. And E2 by default keeps the same OSPF cost across the entire OSPF network. Okay, look at this. The metric for the default route is 1. And on R1, the metric for 192.168.10 is 10. A default static route imported into OSPF is given the metric type of E2 or external type 2 by default. And external type 2 by default keeps the same OSPF cost across the entire OSPF network. In this case, the metric for the default route was 1. So it has a metric of 1 everywhere in the OSPF56 network. The 192.168.10.24 network is an internal OSPF route whose metric is cumulative.